Okay, good morning. I'm going to explain about that data processing instructions. So now, last two previous classes, I started with the assembler basics and instruction sets. So in this instruction set, we have uh, two set of instructions. One it is called as harm instruction. It belongs to the 16-bit instructions, and another set of instruction it is thumb instruction. It they belongs to 32-bit instructions. Now the few instructions list of instructions I was discussed in the last class. 16-bit data processing instructions, uh, branch instructions, and load and store instructions, and some additional instructions also we listed out. Now today, instead of I'm giving the list of 32-bit instructions, I will going to explain few instructions belongs to that both harm mode and thumb mode. Harm mode is nothing but 32-bit operation of instructions, and thumb mode is nothing but ARM mode is nothing but 16-bit of instructions, and thumb mode is nothing but 32-bit of instructions. So in these directions, I will take one empty slide. There I will going to explain, and I will write it how data processing instruction executed during the runtime, and all these things related to that few set of instructions I will discuss. First, I'll come to that heading. Please take down data processing instructions. Data. Is it visible slide?
Yes, sir.
Okay. So data processing instruction. First heading. So data processing instructions. Okay. In these data processing instructions. So subheading today's class, I will start shift 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 and rotate instructions. Shift and rotate instructions. Okay. Uh, Shift operations moves the bit in a register left or right by a specified number of bits. The shift length have to be specified. How many number of bits have to be moved or to reallocate it. That is what we discussed in this set of instructions. So totally here shift and rotate instructions, 5 major instructions are available. They are all belongs to that shift instructions. These instructions will be called as, so one it is called as logical shift left, logical shift right, arithmetic shift right. Okay. Then rotate right, and then rotate right extended. These 5 instructions to be discussed today with suitable example. Okay. Now, first I will start with that first instruction. It is called as logical shift left. Please take down logical, yes, LSA, logic shift left instructions. Please note down full form. Logical shift left instruction. What for these instructions? The number of specified bit shifted towards left, and MSP goes to the carry bit, and LSP so added 0 bits. So I will write it. See here. That is what the representations. This is what the registers, and here will represent carry, and here will be represent. So from MSP 0 is introduced. So this is what will be written as register. Please take down. So this is what is called as REGISTER, registers, and this is what we call as carry. So this is the direction is very important towards left. See, please all of you look into this. Okay, here, and now 0 is introduced from LSB here. So as per our statement, we know this is called as LSB, least significant bit, and this is called as MSB, most significant bit. So in this case, logical shift left, the specified number of bit shifted towards left. The MSP of the register goes to the carry bit. It go to the carry, and zeros are introduced from LSP. So suppose I want to specify 4 bits of data shifted towards to the left, 4 zeros are introduced from the LSP. Are you clear this? This is very important. And now I will take some suitable examples for these LSI instructions with syntax. The way of writing the syntax is very important. For example, so please take down the example. So the example written LSL logical shift left. So RD comma RN comma hash immediate IMMED immediate. Suppose I can take these instructions. What for these instructions? See, I will clearly explain that. What is the role of these instructions? So before that, we should know that apparents. Already I explained this. This is called as opcode. We have 3 apparents. See, RD is a one apparent, apparent 1, apparent 2, and apparent 3. First apparent always, I told in the last class, it is called as a destination. And second apparent, it may be a source. But sometimes we use third apparent also, we specify that numbers. Because in this case, in these instructions, we using immediate value. The hash is indicates for immediate value we are going to assign. So what for these instructions? It is very important. So before that, please note down RD equal to destination registers. Please all of you note down RD equal to destination register, and RN equal to register holding the value to be shifted. Register holding the value to be shifted, and then finally immediate, it shift the length or how many places we are going to shift. It is what they indicate for that. When we are using 3 apparent, first apparent is destination, second apparent is specified register data. So here this is register data what we have, which data to be shipped, they have to be specified, and RN is number of bits to be shipped. Maybe shift left or it may be shift right in future instructions, but have to be specified. Almost similar syntax I will tell you in next instruction also. Okay, and then comments. Comments should be very important. You should write the comments. Comments. So here RD destination register equal to, okay, RD equal to N shifted towards left. That is what the left direction. And what value it will be shifted? So immediate, immediate, the specified bits of data shifted towards the left. Are you clear this? This is what is called as LSL instruction. And similarly, in LSL instruction, with two apparent LSL instruction, I will consider some program. Instead of we looking into the four apparents, it is a bit complex. So not required to use three apparents in some cases. By the time I'll going to use only two apparents. If you use only the two apparents, for example, the second example, so L S L logical shift left, then R D comma R N. What for this instruction? See, all of you look into these instruction. For this instruction, so destination address is nothing but the holding the value to be shifted. Means that RD, that value will be shifted. How many number of bits? Rn. So immediate value here is not specified. That value you have to load it into the Rn. How many bit data to be shifted, that it will be specified by Rn, and then Rd is the holding the value to be shifted. The value of Rd shifted towards left specified bits by Rn and result stored in the Rd only. Result stored in the Rd only. So here not mentioned, please here Rd equal to this much. This is what syntax. Rd equal to Rd. This is what the syntax for this. So not only this instruction, almost all the instructions we are doing like this only. This is what called as LSL registers or logical shift left. But what I explained, this is only for 16-bit ARM mode of instruction, ARM mode of instruction. The same instruction I will run with thumb mode. Thumb mode is nothing but 32-bit operation. By the time, please all of you consider this LSL dot W. Apparent should be like this. LSL W, then apparent, as usual apparent. Apparent it may be a, so RD comma RA. So the syntax also same, RD equal to the RD destination location shifted the number of bits specified by Rn, but it is a 32-bit LSL 32-bit. So this is what the syntax and way of operation. Everything it will be similar in this mode also. Only we are going to change LSL dot W. Unchanged flag. Flag also unchanged. Because some instruction, some flags are affected. Maybe carry flag, zero flag, negative flag, some kind of flag, parity, auxiliary carry, some kind of flags are reflected when they execute these instructions. But even if you go to the thumb mode, even same kind of or same flags are affected. It is called as flags are unchanged. This is what it's called as logical shift left. Okay, now I will go to the next instruction. The similar instructions I will going to discuss. That is called as, this is called as, one more slide I will come to consider. Yeah, here. Now I look into that. Here the another important LSR. LSR. Please take down. LSR is nothing but logical shift right. Logical shift right. So here the representation. So please like this. This is what carry. Okay. And this is we called as registers, carry, and the directions. All of you look into these directions like this. Zeros are introduced from MSB. So this is MSB. MSB should be specified here. MSB most significant bit, least significant bit. So LSB goes to that here, this side, carry positions, and the registers, each bit like this, number of bit shifted. So totally how many bits here? So if you want, please take them 0 to, if it is that, that is what I'm usually not mentioned. If it is in the thumb mode, we can consider 0 to 31. Okay, that is what the number of bit shifted towards right. Okay, and zeros introduced towards the MSB bits, and all MSB bits shifted towards right based on number of bits we are going to shift it. That it will be decided by the apparent. During the apparent, they specify. So example. So now we'll take example. LSR. Okay, same thing. RD, comma, RN, comma, immediate. The syntax should be RD is equal to RN shifted right. How many bits shifted? Specified by immediate data. This is what one syntax. And another syntax, so LSR RD comma RN. The syntax should be RD equal to RD holding data registers shifted right at specified number of bit indicated by RN. If it is 3 apparent like this, if it is 2 apparent like this. So please don't confuse, this is RD. I'm not using pen to write this because I'm using iPad. I'm writing only the finger. So please understand it. This is what the way of declaring it. So here somebody have some doubts or some confusion with, sir, what is RN values? Before that, you have to store the R values. For example, you can take one more small example. I'll consider LDA or LDR, LDA, RN, hash 4, then LSR, RD, comma, and sorry, one more instruction I'll introduce because you can take suitable example to analyze it. So similarly, LDA or LDR, RD equal to immediate value we have to assign 1, 2, 3, 4, 5, 6, 7, 8. With hexadecimal, we should write here, we should write 0 like this. You have to start from here if it is in the hexadecimals. Okay, then I can use LSR, RD, comma, R. RN, how many number of bits we are going to shift? See, please look into this. 4 bits. And RN, the Rn will be specified 4 bits of data to be shifted towards to the right. RD, the register value should be like this. 32-bit register we are using here. 32-bit. 1, 2, 3, 4, 5, 6, 7, 8, like this. Okay. So now to execute this instruction, the content of RD 1, 2, 3, 4, 5 convert into the bits. Shifted RD is equal to RD shifted right with specified bits. 4 bits you have to be specified. So now I can take example. Okay, now I can take example. Sorry, I will take the example. Yeah. So see here, look into this. Split into the 32 bits. So split into the 32 bits. If you split into the 32 bits, first you can divide half, 16-bit, 16-bit, then 8-bit by 8-bit, then 4-bit, like this. This is what we are splitting it. So each again splitted into the 8 bits. So this is what I given the data. So I'll return the data. So from lower bit 8, 7, 6, 5, 4, 3, 2, 2, 1. But you should write it in the convert into the binary numbers. 8 binary numbers. What is the value of 8 binary numbers? 1, 1, 0, 0, 1, 0, 0. That is what you can split into this line. Similarly, you can split into these 4 bits. Similarly, you can split into like this. Okay. Similarly, you can split into like this. Like this. So totally we have 32 bit. So like this. So like this. Now you can write the all binary numbers. 1 means binary numbers, you should write 0, 0, 0, 1. 2 means 0, 0, 1, 0. 3 means so 1, 0, sorry, 0, 0, 1, 1, like that. Now how many bit of data have to be shifted? The shifted right at given as in the previous example 4 bits. So 4 zeros are introduced from here. 4 zeros are introduced from here means, so what is the final value? Anybody's? What is the final value? Just you have to guess it. 4 zeros is introduced. So it becomes 0, 1, 2, 3, 4, 5, 6, 7. After the execution, the 7. This is these all 4 bits shifted towards goes to the carry. So after the execution, you are getting RD value is equal to before execution, RD value is equal to 1, 2, 3, 4, 5, 6, 7, 8 hexadecimal value. And after the executions, so 0, 1, 2, 3, 4, 5, 6, 7, sorry, 7 only. Yeah, this is what. Okay, 7. So this is will be called as before execution. This is will be called as after executions. Okay, this is what the shift instructions. Now the 2 instruction part is over. Now next we'll start with another instruction called as
RN4 ಅಂತ ಕೊಟ್ರೆ ಬರೀ 4 ಬಿಟ್ ಇರೋದು ಅಷ್ಟು ಮಾತ್ರ, ಬರೀ ಅದ್ರಲ್ಲಿ ಒಂದೇ ಬಿಟ್ ತಾನೇ ಹೋಗಿದಲ್ಲ ಸರ್?
ಒಂದು ಅಲ್ಲ 8 is equal to 4 ಬಿಟ್ ಅಲ್ವಾ, ನಾವು ಬಿಟ್ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ ಎಷ್ಟಾಯ್ತು? 8 ನ ಬೈನರಿ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ 8 ಬಿಟ್.
ಬಟ್ ಅಲ್ಲಿ RN ನಾವು ಕೊಟ್ಟಿರೋದೇ 4 ಅಲ್ಲ ಸರ್, ಹಂಗಂದ್ರೆ
4 ಬಿಟ್ಸ್ 4 ಬಿಟ್ಸ್
ತಗೊಬೇಕಲ್ಲ ಸರ್? ಹಂಗಾರೆ
ಇಲ್ಲಪ್ಪ, 4 ಅಂದ್ರೆ 4 ಬಿಟ್ಸ್. ನಾನು ಆಗ್ಲೂ ಹೇಳ್ತಾ ಇದ್ದೀನಲ್ಲ 4 ಬಿಟ್ಸ್. That value to be specified how many number of bits to be transferred. If it is 4 means, so but the number we are not specified binary.
3 ಬಿಟ್ಸ್ ಕೊಟ್ರೆ ಸರ್, ಈಗ 3 ಬಿಟ್ಸ್ ಕೊಟ್ರೆ
3 bit convert ಆಗೋಗುತ್ತೆ. ಅವಾಗ ನಂಬರ್ಸ್ ರೀಶಫಲ್ ಆಗುತ್ತೆ. 3 ಬಿಟ್ ಹೋದ್ರೆ ಫೈನಲ್ ಆಗಿ ಏನ್ ಉಳ್ಕೊಳ್ಳುತ್ತೆ, 1 ಉಳ್ಕೊಳ್ಳುತ್ತೆ ಈ ಸೈಡ್ ಅಲ್ಲಿ. ಸೊ 1 ಇಲ್ಲಿ 7 ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ಸೊ ಅಲ್ಲಿ ಏನ್ ಬರುತ್ತೆ ಅಲ್ಲಿ ಲೆಕ್ಕ ಹಾಕಿ. ಬಟ್ ಈ ನಂಬರ್ ಚೇಂಜ್ ಆಗುತ್ತೆ. ನಾನು ನಿಮ್ಗೆ ಈಸಿ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಗೆ ತಗೊಂಡೆ 4 ಬಿಟ್ ಅಷ್ಟೇ. ನಂಬರ್ ಆಫ್ ಬಿಟ್ಸ್ ಟು ಬಿ ಸ್ಪೆಸಿಫೈಡ್, ಹ್ಯಾವ್ ಟು ಶಿಫ್ಟ್ ಇಟ್ ಟುವರ್ಡ್ಸ್ ದ ನಂಬರ್ ಆಫ್ ಬಿಟ್ಸ್, ನಾಟ್ ಫಾರ್ ದಟ್ ಬೈಟ್ಸ್.
ಸರ್ ಅದೊಂದ್ಸರಿ ಹೇಳಿ ಸರ್, 3 ತಗೊಂಡ್ರೆ ಹಿಂಗ್ ಬರುತ್ತೆ ಅಂತ. ಯಾಕಂದ್ರೆ ಒಂದೊಂದ್ ಬಿಟ್ ಚೇಂಜ್ ಆದ್ರೆ ನಂಬರ್ಗಳು ಇಲ್ಲಿರೋ ನಂಬರ್ ಎಲ್ಲ ಚೇಂಜ್ ಆಗುತ್ತಲ್ಲ ಸರ್.
Yes, okay. I will write it. Just all of you, please. I will clarify this. I will write it first. I will write that first before execution. 1 2 3 4 1 0 0 0 1 2 0 0 0 1 0 3 0 0 1 1 4 1 4 0 1. That is mistake. 4 means 0 1 0 0 5 0 1 0 1 6 0 1 1 0 7 0 1 1 1 8 1 0 0 0. This is what we are considered. Better you group it. This is 4 and this is 4 bits. This is 4 bit. This is 4 bit, like this. Now I hope that clear. This is indicate 1. This is 2 3 4 5 6 7 8. Now suppose I will shift it into the 3 bits. Please all of you just be careful. Suppose I want to shift into the 3 bits. So Rn equal to 3 bits. 3 bit I want to shift. So here please look into that. 3 zeros are introduced. 3 zeros are introduced and 1 0 it will be left. So this is left, considers one number, and then 0 0 1 0. Then 3 bits it will be considered. So 3 zeros to be introduced means so, and sorry, I will write it. Now we are taking this is 3 zeros plus 1 0 4 0 0 0 1 plus 1 0 will be considered. Yeah, I will write that 0 1 0 0 0 1 1 0 1 0 0 0 1 0 1 0 1 1 0 0. So next byte next I'm supposed to write this one here. What will return that 1 1 1 1. So now it is please mark it 1 2 3 4 5 6 7 8. So now the final value will become after the executions. This is called as 0. This is 2. This is 4. This is 5. This is 8. 8. And this is it correct? No, 8. Yeah. And this is 8 plus 1 9. And the last one it is what it is called as F. 8 plus 4 12. 12 plus 2 14. 14 plus 1 F. Last number it is F. So this is what it is F. So after the execution,
sir, after 4 it is I think 6.
6 sir. ಆಮೇಲೆ 4 ಆದ್ಮೇಲೆ 6 ಬರುತ್ತೆ ಸರ್.
4 2 6 ಸಾರಿ.
ಆಮೇಲೆ ಇದು 8 ಆದ್ಮೇಲೆ 10 ಅನ್ಕೋತೀನಿ ಸರ್.
8 plus 2 10. 10 ಅಂದ್ರೆ ನೀವು A ಅಂತ ತಗೋಬೇಕು. ಸಾರಿ, ಕರೆಕ್ಟ್. 10 it should be take A, hexadecimal A. This is F.
C ಅಲ್ಲ ಸರ್ ನೆಕ್ಸ್ಟ್?
ಇದು C. Yeah. Then F. Yeah. This is what before execution and or after execution. This is what we are getting. Okay. The similar way you have to be practice. Number of bits.
F ಬರಲ್ಲ.
Pardon?
C ಆದ್ಮೇಲೆ E ಬರುತ್ತೆ ಸರ್. F ಬರಲ್ಲ ಸರ್.
E ಬರುತ್ತಾ? ಇಲ್ಲ. All 1 1 ಬರುತ್ತಲ್ಲ. All 1 1 ಬಂದ್ರೆ ಎಷ್ಟು ಆಯ್ತಪ್ಪ?
All 1 1 ಅಂದ್ರೆ 15 ಆಗುತ್ತೆ ಸರ್ ಆಡ್. 10 ಆದ್ಮೇಲೆ 12, 12 ಆದ್ಮೇಲೆ 14. 8
plus 4 12, 12 plus 2 14 15. 15 ತಾನೇ ನಾವು ಎಫ್ ತಗೊಳ್ಳೋದು. ಎಫ್ ಇಸ್ 15 ಅಲ್ವೇನ್ರಿ?
F is 15, sir.
ಹೌದು, ಕರೆಕ್ಟ್.
Okay, sir.
Okay, I think the concept you have to follow that concept.
Yes, sir. Thank you, sir.
Okay. But if using blackboard is very convenient to write and all these things. I'm using iPad. By finger only I'm writing it. It's very difficult to write it. Very not clear. Okay.
Okay, sir. Okay, sir.
Okay.